Well, we first need to check if this multiplication is even possible, and we need to do that by looking at the size of each of these matrices. So our first matrix, we have 2 rows and 2 columns, so it's a 2 by 2 matrix. Our second matrix has 2 rows and 4 columns, so it's a 2 by 4 matrix. In order for the multiplication to be possible, these inside dimensions here need to be the same, and so they're both 2 this time, and that means that we can in fact go ahead and find this product. Now the product, or our answer, is going to be a 2 by 4 matrix, as indicated by these outer dimensions. So we'll start by finding our entry in the first row and first column of our product or answer matrix. And so that's going to indicate to me to use the first row of the first matrix and the first column of the second matrix, and multiply their corresponding parts and add those answers. So 1 times 2 plus 3 times 0. So that gives us a 2. Now we'll go ahead and stay in the first row and move on to the second column. So I've used the first row of the first matrix and the second column of the second matrix. So I get 1 times 3 plus 3 times 5. So that's 18. And then we'll move to the first row, third column entry. So we're using the first row of the first matrix times the third column of the second matrix. So that's 1 times negative 1 plus 3 times 4. So that makes 11. And then our first row, fourth column, we get 1 times 6 plus 3 times 1. So that's 9. And then we've run out of columns in our second matrix, so now we need to move down to the second row of the first matrix. So second row, first column, we'll get 0 times 2 plus 2 times 0. And we'll use the second row and second column. We'll get 0 times 3 plus 2 times 5. So that's 10. And then our second row, third column, we'll get 0 times negative 1 plus 2 times 4, so that's 8. And then our last entry, using the second row and fourth column, gives us 0 times 6 plus 2 times 1. So that's 2. So our product matrix is here, this 2 by 4 matrix. And if we want to kind of verify that all of our operations here were correct, if I look in these first 4, I see 1 and 3 right there in those spots, and that's because those are the entries in the first row of the first matrix, 1, 3. So those should all be the same. And as I go down, looking at the numbers in parentheses down that list, I get 2, 0, that's the first column of the second matrix, 3, 5, that's the second column, negative 1, 4, that's the third column, and 6, 1 is the fourth column. Okay, then we see a similar type of pattern here in the next 4 calculations. We have 0, 2, those are the entries in the second row of the first matrix. And then again we have the first column, 2, 0, second column, 3, 5, third column, and fourth column.